Now let's quickly look at the linker and loader functionality and take an overview. But we'll very much we'll touch this topic on the very surface of it. This is more of a topic of your compiler class and operating system class. Just to make our overall picture clear and have a global picture around us, we just touch on this topic, linker and loader. The linker I have explained, I think, in earlier slides in more detail, but it's the same here. Basically, it picks up object files generated by the assemblers, and if there is any symbol which is part of the library object code, it also pulls out that specific part of the code and put together and stitch together all the object files to generate an executable. So, so its functionality is like search the library to find out library routine used by the program, determine the memory location of each module, resolve the references among the files, and then it ultimately stitch together, create an executable code for it. Now the loader is outside the compilation process. Like compilation process, by that mean it invokes the compiler, which generates an assembly code. Then it invokes the assembler, which generates object code. Then it invokes the linker, which stitch together all the assembly code and generate an executable. So there the compilation process ends. Compilation of the high level program ends. Now you invoke your executable, right? In the Windows environment or Mac environment, you basically double click on your app and you start running. In the Linux or Unix like environment, you basically typing the executable code on a shell prompt and it's just start to run, right? Now what goes behind that scene, right? So what happens when you type in or double click on executable, operating system intercept that action and call something tool called a loader. Okay, so loader loads the executable in the memory and start the program to execute on the system. How does it do? First of all, your loader, in terms of operating system, loader is a part of operating system. So in this discussion, I'll interchangeably use the loader and operating system. But anyway, it determines the size of the text and the data segment in the executable. Okay, so first look at the executable, and there are some part that has information that how big is the executable or code section, how big is the constant data sections, and so on and so forth. Then it creates a new address space for the program. So operating system goes and check, okay, how much memory is free, where I can actually copy this executable text and data segment into the memory. It kind of determines that at the runtime, and then copies the instruction and data from the executable file into that memory location, then copies the arguments to be passed to the program onto the stack. So right now it probably becomes more abstract for you, like what is meant by stack and so on and so forth. Just hold on to this thought. We'll be discussing this passing argument through the stack in more detail when we start discussing our function implementation in assembly language. Okay, so but it somehow it passes your arguments that you are passing into the executable into the stack to communicate with the program. Then initialize the machine registers. Stack pointer point to the free stack location. Again, this will be stack pointer and stack location. This will be discussed in detail in successive lectures. Then jumps to the startup routine of the that copies the argument from the stack to the registers and call the main routine. So this is very important. So remember, all your program needs to have a function, high level program needs to have a function called main. Why is so? Because your operating system and loader kind of assumes that the standard name of a function or a procedure from where your program starts. So it goes So at the lower level, what it does, it jumps to the startup routine that also copies the arguments for that startup routine to send it into the function or the procedure called main. And there it start executing your program. Okay. So that's the function of the loader. So these two parts really we kind of touched at the very surface, and I hope when you take operating system class and also the compiler class, you will get more details view of what exactly goes on in detail and so on and so forth. But right now we should be okay with this global picture, like from a high level code, how the executable is generated, especially detail in the assembling process, assemblers with the directive helps and stuff like that, and then how that executable is executed in a machine. So most important part in this lecture is your assembler process, pass 1, pass 2, and how the codes are generated, and also the assembler directives, especially your data layout and macro concept and pseudo instruction.